is the general form of a quadratic function. The graph of a quadratic function when a is greater than 0 is like this, and we see there is a minimum value. We can find the coordinates of that minimum value by a method called completing the square. We halve the number next to the x term, the coefficient of the x term. We square that answer. We write this as added on, and then we write it as subtracted off. As a result of doing this, the first three terms can now be factorized as a perfect square. For example, y equals x squared plus 8x. We halve the coefficient of x and square it to add 16 on, and then take 16 off. As a result of this, we get a perfect square from the first three terms of x plus 4 multiplied by x plus 4 minus 16 still there, which becomes x plus 4 all squared minus 16. Because x plus 4 squared can't be negative, the minimum value of the function is minus 16, and this occurs when x plus 4 is 0, that's to say when x is minus 4. This is the form of a quadratic equation. On a graph, the solutions are where the curve crosses or touches the x-axis. The solutions can be found by factorization in some cases. In other cases, we can use the method of completing the square. Here's an example. X squared plus 6x plus 6 equals 0. Coefficient of x is 6. We halve the 6 to get 3 and square it, add it on and subtract it off, and the plus 6 is still there. Now we can factorize the first three terms to get x plus 3 multiplied by x plus 3 gives us the perfect square. X plus 3 squared equals 3. X plus 3 equals plus or minus the square root of 3, and then x equals minus 3 plus or minus the square root of 3. If a quadratic function has a non-unity coefficient for x squared, that coefficient can be taken out of a bracket and the method of completing the squares applied to the contents of the bracket. For example, y equals 2x squared minus 10x. We can take 2 out as a factor, leaving x squared minus 5x in the bracket, and then we can complete the square on that, which leads to x squared minus 5x plus 25 upon 4 minus 25 upon 4. From this we can factorize the first three terms, leading to 2 brackets x minus 5 upon 2 squared minus 25 upon 2. The minimum value of the function is minus 25 upon 2, and this occurs when x is equal to 5 upon 2. If a quadratic equation has a non-unity coefficient for x squared, the equation can be divided by that coefficient, and then the method of completing the square applied. For example, 2x squared minus 8x plus 7 equals 0. We divide by 2 to get x squared minus 4x plus 7 over 2 equals 0. We halve the coefficient of x, which is minus 4, becomes minus 2, squared becomes 4, add the 4 on and take the 4 off. This allows us to complete the square for the first three terms. As a result of that, we get x plus 2 all squared equals a half. We can square root both sides to get x minus 2 equals plus or minus the square root of a half, leading to the solution x equals 2 plus or minus the square root of a half.